Hi, everybody. Thank you so much for joining us. We're going to wait just about another 60 seconds. It's a minute after already, so I promise it won't be long, but we'll just wait for those last-minute stragglers. This is over lunch in some time zones for sure, and then we'll get started. Okay, let's get going. Thank you so much for joining me. My name is Patrick Pusher. I'm a technical evangelist here at Orca Security, and today we're going to be spending about the next half hour talking about one of my favorite subjects, and that's sort of the role of context in cloud security. Just a few sort of housekeeping things before we get started. This session is being recorded, so it'll be available sort of post-event on the Orca website. Second is, if you have any sort of performance issues while participating in the cast today, there is a help menu in your top right, and under that help menu there's a troubleshoot connection or some sort of option like that. Please do use that, and it'll sort of help reset and maybe give you a bit bigger of a buffer for a better experience. But use that only if you need to. Hopefully everything is very smooth. So let me just pivot here to more of our slide view. We'll set the stage for what we're going to discuss today. And really that's going to be around, why your security team is ignoring alerts right now. Not to be alarmist, right? But the data is in. And very, very clearly, this is a universal problem, right? And we'll talk about why that is. Next, we'll talk about the state of security alerts and some of the biggest factors that contribute to distrust in alerts overall. We'll then discuss some of the different approaches to solving the problem with a focus on how essential context is with regard to solving the dreaded sort of alert fatigue. We'll then talk a little more specifically about Orca and tie in a bunch of the subject matter of what we talked about in terms of what Orca does. And if we get an opportunity, if we have enough time, I'll pivot and show you live a little bit of the product, and then we'll wrap up at the end with some Q&A at the end of our time together. Okay, so research supplied by SC Media, and this research comes from RSA 2018, told us that most enterprise IT efforts see more than 10,000 alerts a day, right? Over a quarter of enterprise security teams see more than 1 million alerts a day. And if we truly had that many noteworthy issues or security controls to verify, that'd be one thing. But Critical Start and some similar survey efforts found that the majority of security professionals stated that over half of these alerts are false positives. And so those teams tasked with analyzing and acting on these alerts are clearly tuning out, right? Almost by absolute necessity. With that many alerts, and the severity score need not really even exist, right? There will never be an opportunity to address anything but the most severe, and your chances of getting through all of them are really next to impossible. What's more is that sources of noisy alerts will get turned off or tuned down, and then you risk missing, really, really important and meaningful alerts in the sea of them all, which can lead to disaster, as we learned about sort of back in 2014, right? Back in 2013, a data breach happened with a retailer really trying to make the shift to online transacting that exposed about 40 million customer credit card details, among other things. Much like we've already spoken about, the security team there had actually received alerts about the presence of malware on the network from a threat detection tool, but the overburdened team chose to ignore those alerts, right? Because they were so common, right? The famous sort of boy who cried wolf syndrome. Well, by now, the rest of the story. That retailer is still paying customers who are victims of that data breach, in 2021. A study by Enterprise Management Associates titled "A Day in the Life of Cybersecurity Pro" places the overwhelming challenge into sort of a business context, right? And points out that it has real and tangible costs. EMA writes that analysts waste over half of each day looking for problems that are either insignificant or not really problems at all, right? Combining the number of alerts with the complete lack of actionable intelligence associated with them is a recipe for massive waste, and ultimately lays the groundwork for risky configurations that go unknown to the business to emerge, often existing for long periods of time before they're being detected, or much worse, before being exploited. CSA teamed up with McAfee a few years ago and reached out to security professionals in a study that aimed to better understand just how widespread the problem of alert fatigue really was. And they found that enterprises consistently had multiple tools creating multiple alerts that their security operations team were charged with pursuing and ultimately fixing, right? And their challenge in that, they said, was that almost half of the alerts received didn't have enough information in them to be actionable, right? And so far more information was sort of needed to start the triage process. And one of the key areas of functionality for SOAR, or security orchestration, automation, and response platforms, is to collect information or context associated with a particular alert to assist in the triage of that issue and ultimately to resolve it. Nearly a third of respondents stated that they ignore alerts because they know, or, and this is really key, they think they know, that they're false positives and are simply the result of rigid security tools or poor process. So the financial implications of untrustworthy alerts, they're harder to determine, but they're numerous, right? The wasted time associated with trying to make sense out of an ever-growing stream of often irrelevant alerts is worth more than $1 million per year for enterprise IT. It's difficult to think about how any other discipline in IT would tolerate that sort of misspend on a perpetual basis, but it speaks to the state of poor IT alerting right across the board. And one of the largest reasons for these surprising figures is our emerging focus and enterprise-wide adoption of public cloud, right? It's one thing when a single business unit or project team begins to leverage the public cloud, but when an organization does so across many different disciplines or business units, there are varying levels of cloud and security maturity that go along with that, as you'd expect. So this is the largest factor in deciding to form those central governance and risk teams to watch over cloud usage as a whole and ensure that the enterprise is adhering to security best practice, as well as measuring security controls that are mandated by more formal regulation, if that's applicable, of course. And so IT and security teams are really being hit hard on both sides, right? On one side, they're flooding their SOC team with a flow of alerting information that is sure to burn out staff that are tasked with, the responsibility of keeping their cloud assets secure. And then on the other side, when they do burn out staff, they're finding it really, really difficult to replace that modern, mature cloud security knowledge. According to a Frost & Sullivan report a few years ago, we're still having significant challenges finding the right staff with the right experience. And this is absolutely the case within public cloud security. Anecdotally, in conversations with Orca customers last year, this was still among the top 3 concerns of our customers, right? They found that hiring a cloud security skill set isn't easy, and it's partly due just to how quickly these platforms evolve and debut new functionality, but also just the rate of change of services that offer an instantly available platform for new ideas, right? No procurement delays, ubiquitous global performance, and sort of seemingly infinite scale all contribute to massive adoption, and subsequently security is often sort of lagging behind. So this slide attempts to convey a few different ideas, so let's spend some time sort of unpacking this and breaking this down. In terms of cloud security, we have 2 different categories of security tools and capabilities, right? We have what we call cloud workload protection platforms, or CWPP. That's a Gartner term. They measure workload-specific risks like software vulnerabilities, malware inside of workloads, host or container-based misconfigurations. In that workload category, we put regular VMs. We call those instances on some platforms, containers, all of that. And then to measure the state of your cloud security controls and compare them to either formal standards or best practices, we rely on a second sort of category of tool. We call that the Cloud Security Posture Manager, or CSPM. And both are really required for a holistic approach to cloud security, and both have distinct limitations traditionally in how they consider and score risk, right? Don't worry about straining your eyes on each example on the slide. On the next one, we'll blow them up and dig in a bit deeper. But on the left-hand axis in those blue boxes, we have the types of resources we consume from public cloud providers. And you'll notice that applications straddles that line between CWPP and CSPM. If you're leveraging instances and containers for your apps, then you require a host-based CWPP approach. But if that same app also leverages some serverless functions like Lambda or database as a service offerings, from your cloud provider, which most do. You'll also require that CSPM capability to ensure your cloud security controls associated with each of those services are configured properly and do not change. With each different cloud security approach, we have different and significant challenges and limitations around how we calculate risk. So diving a bit deeper into these examples, let's tackle cloud workload protection platforms first, right? Here, the challenges are many, but let's focus on the top two. The first is that the default practice of just about every solution in this space is to adopt the CVSS score of a discovered software vulnerability as the absolute risk score without any further consideration of the environment around that workload, right? The security groups around it, the networking around it, that sort of thing. The second is that because CWPP platforms integrate per asset, meaning that you install workload agents in each instance or each container, their ability to understand context of what is around each workload in terms of cloud services, even the firewalls that govern access in and out of them, is really limited. All right, so if we shift to CSPMs, we find that risk is hard to judge accurately with only a perspective on cloud security controls, but not the data that lies underneath them, right? CSPMs ask questions of cloud service provider APIs, the AWSs, the Azures, or the GCPs of the world. Questions like the state of storage bucket controls. How many times have we read in the press around, S3 buckets staying wide open? That's squarely the responsibility of a CSPM. Or to identify and access management policies like multi-factor authentication, right? Or the specific users around, or specific policies around, login attempts for user accounts, for example, in the cloud. But these CSPMs don't understand the data inside of the storage buckets, for example. And that means often a mismatch between security controls and data sensitivity, right? It also means that severity is relative, and the top alert about default security groups that you see on that slide is ranked as the very highest severity, even though resolving this for me will do very little for my overall security posture, right? As those groups are in regions that I simply don't use. So to be clear, it's not worthless information, and there is something I can do with it to reduce the risk of these security groups being, reused and reassigned to workloads in the future, for example. But that sort of alert should never take precedence over something that's directly actionable, right, and can make a tangible difference in my overall security posture. And this is how we get into that problem of an overwhelming number of alerts, all at the highest severity. So it's for this reason of siloed perspective, among others, that Gartner really did predict that CWPP and CSPM solutions will merge into single solutions and offerings. And we've seen that happen right across the industry, mostly through acquisition, right? And I think Orca is the first and the best attempt I've seen to build a solution from the ground up organically with these kind of two pillars built into it. More importantly, though, with these two pillars sharing information back and forth. And we'll talk about that more very soon. And so the vast majority of cloud security solutions really only consider, one dimension of risk, the severity of an underlying security issue as it's been judged, by others. This invariably ends up treating your cloud as a long sort of list of alerts that lack context, and it leaves you exposed. And as we talked about before, the real risk is causing this alert fatigue where trust in alerts in general really goes down. But the risk is much more than the severity of that underlying security issue, right? We see it three-dimensionally. Risk involves not only the severity of the underlying issue, but also its exposure, who has access to take advantage of that issue, and what's the blast radius, right? If something does go wrong, what is the potential impact to the business? What can that particular deviancy touch if exploited, right? Those are all really important questions to ask as we risk alerts. So if we think of risk pragmatically as this potent three-way mixture of external risk indicators, like the CVSS score of a software vulnerability, the exposure associated with the detected risk, and therefore, its likelihood to be exploited, and just what that risk can touch or has access to if exploited, we've got a much more accurate idea of just how severe any given risk truly is. And we hear a lot about machine learning and artificial intelligence to learn and point out anomalies in user behavior and service consumption across the public cloud. certainly while some inference based on previous patterns can be useful, it can also significantly add to the false positive noise when it's wrong. And that's something we're specifically trying to solve for when we think about context. And so ML and AI certainly do have their place in predictive analysis, but leaving the consideration of context on the table, I think, is a massive mistake, because it's our best means to separate what's truly important and needs action now versus what can wait. So let's do a very small exercise to better illustrate how context can help a drowning security operations team, right? If you consider server 1 and server 2 on this slide, you can see that they're both running a web server that uses a vulnerable library, vulnerable to remote execution risk for the sake of this example. And as you can see, the vulnerability in both cases is exactly the same, and therefore carries the exact same high CVSS score, right? So far, so good. A contextless approach to the problem would simply report this vulnerability with its static CVE score, and both workloads will end up getting the exact same risk score, which means the exact same risk categorization, which means the exact same amount of time will be spent on each of these alerts, right? And that's to say if they get acted upon at all. Imagine if hundreds and thousands of the high severity alerts every day. It looks like we have a little bit of audio performance. Hopefully we're okay, but I see a couple observations in the chat. We will absolutely have the recording. If you do have performance issues, again, please do use that help menu in the top right. But hopefully you can hear me okay. So what if, however, we considered a lot more than the CVSS score, right? If we consider the environment in which this risk was found, we can tell that the service on server 1 is internet facing, and therefore the risk is classified as an imminent compromise. Whereas server 2 is not internet facing, and in fact can't be reached directly from anywhere but a single other host. And therefore the risk level has been downgraded to medium. It's not to say it's not important, but it clearly should not carry the same weight or risk level as the workload with the CVE that is public facing. A very basic example, but it serves to illustrate the point that context is absolutely mandatory in any security strategy, right? With thousands and thousands of alerts, you need to know which ones, if not addressed, would likely lead to compromise, right? And therefore require action right now versus those that are more informational and can wait longer in the queue. So, at Orca, we've purpose-built a cloud security platform that delivers workload deep intelligence, but also cloud-wide risk discovery, and in fact uses observations from either side to inform risks found in the other. I mentioned this earlier, right? So for example, when Orca finds software vulnerabilities on a host, right? And as we reviewed in our high-level example just a moment ago, a number of contextual factors are considered, like cloud network accessibility. That's the one we talked about in our example last, but there's certainly more. Age of vulnerabilities, known exploitation paths, whether it's kind of trending and current and therefore talked a lot about more in the media. These are all things that add or subtract weight from that risk score. Orca's agentless, right? And it deploys across your cloud account once instead of having to install and maintain an agent inside of each workload. And it provides really, really deep intelligence about configuration, misplaced sensitive data like PII, indicators of potential lateral movements, the discovery of malware, and a lot more. We often talk quite a bit more about that agentless process and the technology we use to power that, called side scanning. We don't have quite that much in this presentation, but we certainly will have in many more. And it's a huge differentiator in terms of Orca versus other solutions. If we have a chance to get the demo with looking at the clock, I think we will. I'll focus in on that more. Just before we do, one of the things we really like to talk a lot about, we talk about context as it pertains to judging risk score, but there's other ways of thinking about context within the Orca platform too. And one of our customers went on record last year in a webinar we did with them, talking about how they like how Orca sort of aggregates findings up to higher level, single actionable kinds of things that can really help you resolve many CVEs kind of at once. And we call that alert aggregation, and we'll talk about that in the product. But that's one of the things that our customers find a lot of value in, and it's a unique capability of Orca. With that, let's take a look at the product. I am just going to stop my screen share for a moment, and then I'll restart it. Somehow my screen share control, oh, here it is. Okay. I'll zoom that up just a bit. So welcome to your Orca dashboard. One of the first things we often do, and I'll do it very quickly because we don't have that much time together. I do want to get time for just a little bit of Q&A, is the deployment of Orca, right? When we think about other solutions, especially those that are in that CW PP space that talk about software vulnerabilities and risks on host, right? Every other way to deploy those, again, is per asset, right? Installing an agent directly into each resource you want to protect. Orca is very, very different. You deploy once and only once. You deploy at that cloud account level. In the case of AWS, it's with a role and a policy, very, very similar across the other platforms we support. And the idea is that you deploy once, and then from that point on, Orca knows exactly when you spin up a new workload, and it calls for that side scanning process to happen, on discovery, but then obviously kind of regularly through the life cycle of that resource as well. And so one deployment, and never again worry that you're going to miss a workload, because with an agent, you don't know what you don't know. You don't know where you're not protected. With Orca, that's simply not a concern. And so a lot of focus does happen in the dashboard, especially initially as you work through the product. There are certainly other portions. There's a much more comprehensive alert interface where I can work through these with filters on the left-hand side, through severity, through kind of time, through the category of alert, even through the kind of resource I'm looking for. Although if you're looking more for a resource-based kind of inventory, we've got that too. Certainly, it starts with the kind of resource you're looking for. You can drill down, still a very alert-centric interface, as you can see, right? Everything kind of starts with a risk, but useful for more than just kind of alerts. And especially as you think about multi-account, multi-cloud, right? Multi-provider kind of scenarios, having one distinct focused alert, inventory interface is really, really handy. And then compliance, which we'll talk about too if we have time. But let's work through a couple examples of alerts that we referenced to in our presentation today. So malware is a drop dead, easy to understand category. You might think that every single occurrence of malware is risked, super severe, and that's what these red lines underneath each alert say. This is the already compromised kind of alert category. But I'll tell you, if we do find malware that exists on a resource that isn't exploitable from the outside, we will risk it less than, the most high severity. Because again, it's about those largest cases of very, very large cloud accounts that I connect to Orca. I might, when I do that for the very first time, I might find 100 occurrences of malware. Right? It's not about which one should I never think about. It's about which one should I get to first before bad actors do. And that's the idea. Which are the ones most exposed? Which of the ones are made up of malware that is currently being exploited in the wild? These are the things that go into the risking of these alerts. Now, if we look at vulnerabilities, this is a really good example of the aggregation that Michael, one of our customers, talked about, and that we had a slide for, and that I want to show you. So we talk about context and as it pertains to how exposed these things are, among other things, but I think about context in another way as well. So what this alert tells you is that you have a web service that's unpatched. In this case, it looks like it's Apache 2. And Orca goes ahead and says, here is a list of very distinct individual CVEs that you can find in another portion of the product. We'll happily give you that overall list. But what this alert says is, if you go ahead and you upgrade Apache 2, if you modernize Apache 2, you'll take care of all of these at the same time, right? And so again, it's that force multiplier for a very small and efficient SOC team to take and say, oh, geez, that's low-hanging fruit. That was on my list to do anyways. If I test the app with the more modern Apache, upgrade it and get it released out into production, I've taken care of 80 distinct CVEs. And so that's what Orca is always striving to do with not just again, exposure context, but context around, hey, how can we make a security administrator's life easier and help them take care of more with less. Neglected assets is a great category, right? Again, that side scanning process, looks and sees, how old the operating system is, what its patch state is. We do this not just for the OS, but for every application, every library you use. But we'll raise these kinds of alerts that talk about just how neglected this resource has been over time, right? How many CVEs you've sort of picked up year over year of neglect. And there's a couple different levels of severity for this, right? This is an unpatched host OS. You'll also see an alert in the stack for unsupported host OS, which is a different risk profile, right? If it's unsupported, it means I can't go and patch it. There aren't patches available from the vendor. And certainly, we know that, and those with malicious intent know that as well. Lateral movement is another really, really great category to focus on when we think about context, right? So one of the things that Orca does through that side scanning process is look for keys and sensitive information where it shouldn't exist. And in this case, this is Orca finding one half, the private half of a SSH key. And not only that, when it finds it, it has also side scanned all the resources in my account, as we talked about, right? One-time deployment. And so it knows the other half of that key is sitting on these 4 different resources. And worse than that, it's tied to root level access. So if somebody lands on this resource, picks up this private key, they now have access to, at the root level, sort of the all-powerful kind of account, to 4 of my other resources, right? And that's the power of a system that's got a perspective over your whole cloud. It can say, I found a key, and by the way, through the other side scanning I've done separately, I've now matched these together. And not only do you have a private key, you've got an exposure problem and a real indicator of lateral movement risk. Again, all without agents, all without really anything to install. Okay. We're very, very close to an end. I think we will pause there. I know that's an absolute crash course on Orca, and we certainly focus more on the workload risk side than the cloud risk side. Certainly in subsequent webinars in this series and others, we'll focus on the entirety of Orca. But let's pivot back to our slides and let's see what we have for a Q&A. Okay. So one I have here, and it pertains to something I just said, is how does Orca work without agents? There must be something to install. I think install is the wrong word. There's something to deploy, right? You build a role, you assign that role some policy, and Orca only requires read-only policy, right? We have no interest in affecting change in your account, just reporting on exactly what's there, both deep in your workloads and wide in your cloud accounts. But you're in the driver's seat in terms of that information and those rights that you grant Orca. And from that point on, Orca just leverages a cross-account kind of way of accessing that role with the permissions you've assigned, and away you go. So there's never anything to install, no code to install, no executables to run, just that simple one-time sort of deployment method. Another question we have are, what compliance standards does Orca support? Yeah, we absolutely didn't have a chance, a bit of a crash course as we talk about context here today. We didn't have a chance to feature really every corner of Orca, but we certainly do have wide compliance support, both at the host level. So if you're familiar with the CIS standards, we've got those very broadly, squarely pointed at cloud providers and hosts. So application-specific CIS standards, operating system-specific CIS standards for all the modern ones, for sure. Kubernetes, Apache, right? Very specific workload-specific measurements, but then also CIS standards and others, GDPR, some NIST cloud standards, and more coming all the time, squarely focused at the cloud side as well, all your cloud configuration.
Patrick, it looks like there's another audience question asking, how does Orca support a hybrid physical and cloud environment, or even multi-cloud solution, still one account and one dashboard?
Yeah, absolutely. So the multi-count, and that's some of the power of a single Orca account with many multi-vendor cloud accounts connected into it, right? Is sort of governing similar across them all, for sure. But in terms of on-prem support, Orca is really squarely purpose-built for the public cloud, for infrastructure and platform as a service environments. So it's really about those. But multi-cloud in there, absolutely, and a big part of the value prop.
Patrick, it looks like those are all the audience questions that we've got right now. Um, yeah, thank you so much. Let me know if there's anything
Fantastic.
else come through.
No, I think if that's it, that's great. I think we're absolutely at our time now. So thank you. This was our kind of inaugural presentation in the Orca Bytes Present series. So thank you so much for your participation, and I hope you tune into more. For more information on Orca, please do hit up orca.security/demo. There you can tune into a 10-minute kind of pre-recorded demo to get some more information, and then hopefully sign up to get something a little more specific and targeted for you. Thank you very much.
Patrick, there's one more question that just came in if you
Great.
want to answer.
Let's do it.
Isn't there a gap between Orca and other vendors, agent-based, that can scan processes locally and detect threats that way? How do you close that gap?
It's a good question, and I think it more focuses around kind of real time protection as things run, maybe as things go into memory, for example, versus more what Orca's focused on around prevention, right? When we're looking at workload risk, we're looking at, is anything in that workload now that's an indicator of a problem, and that's malware existence is a good indicator of that. But really, it's around what can we find before those with that find a hole into your environment. What can we find for risk configurations really before they do, right? Keeping software modernized, making sure those indicators of lateral movement aren't there or are minimized. So it's more of a kind of Orca squarely focused on the prevention side versus kind of the the real time kind of scenario.
Thanks, Patrick. And it looks like that was the last question.
Fantastic. Thanks, everybody.